All right, we're going to do a couple things today. First thing is we're going to go over Chapter 11 in your book. And after we go through Chapter 11, as we have been doing, we will go through the um, review questions at the end of the chapter. And then the test review. You should have been sent the test review sheets for Chapters 11 and 12 last week. And if there's any time, we're going to do one of the examples at the end of the chapter. All right? For now. We'll look at some more of them tomorrow, but I'd like to get started today. So if you're following along in the book, I'm on page 489, Chapter 11, Exception Handling. I may have mentioned this to you last semester, those of you who were in the class, I don't remember. But when you talk about exceptions in a programming language, they're exceptions to the norm. In other words, they're a bad thing. Okay? And I may have given you this example before, I don't remember. But, I remember when my wife and I, when we adopted our first daughter, and I remember taking her out for a walk the first time. She literally was 3 days old. And we're taking her out for a walk in the neighborhood, and we bought a stroller for her, and a couple people had stopped us and said, oh, how old is she? We told her, oh, she's a cute baby. But no one said this. But typically, it's like you would think if somebody walked by and said, oh, what an exceptional baby, you would say thank you, all right? Because you think of things being an exception, typically an exception to the norm, to being a good thing. But in programming language, it's a bad thing. You don't want exceptions to the norm, all right? You want things to go as they should. So one thing that can happen when you run a program. And let me just show you this. All right, this is something we're going to do tomorrow, but I'm just going to write this for right now. So I'm going to say this. Int x equals 17. Int y equals 0. Int z equals x divided by y. All right. Right line. Okay, so what I want to say here is 17 divided by 0, and I actually want it to show me the answer. Does that make sense? That's what I want to have happen. So I'm going to say here x dot toString, y dot toString, z dot toString. Oops. And if it would work, I would get something either that would say something like I said, either it would say something like 17 divided by 0 is 0, or 17 divided by 0 is undefined, or 17 divided by 0 is infinity, or something like that. Well, let's see what happens when we run this. All right. We get what's called an exception. You may have gotten these before when you've done programs. You may not have. All right. But what we're learning in this chapter is how to avoid having this kind of situation come up. This is called the exception assistant right here. All right. If you close it, you can always reopen it because you see that underneath here, it's got a little red box with an ellipsis in it. And if I click that box right there, it opens it up again. All right. But it says here, system.divide by 0 exception. So in other words, I did something that was against the norm right here. Does that make sense? All right. And when, again, if I say I did something exceptional, you're like, oh, good. No, not good. All right. So we did an exception to the norm right here. So what we're going to talk about in this chapter is how to fix stuff like that. All right. Now, one way that we can fix stuff like that is I could come in here. Okay, I'm going to leave this line here, but I'm going to comment it out. All right, this int x divided by y. Okay, so I could come in here and I could just say int z, and I'm not even going to give it a, oops, I'm not even going to give it a value. All right, I'm just going to say here int z. All right. Now, I could come in here and say this. If if y not equal to 0, z equals x divided by y, and then print this stuff. Else, right line, illegal attempt to divide by 0. All right? And I'll just put a read line here. Okay? So if you look at this, what am I trying to do? Hopefully it's fairly simple to you. But what I'm saying here is I've got two values. All right? And I want to attempt to divide the first by the second. And I'm checking here and I'm saying if the second one is not equal to 0, do it. Otherwise, write illegal attempt to divide by 0. Now, does it make sense to all of you that that's the line that actually should come out when we run this? That should happen. If I've written this correctly. If I made a mistake, then it won't. Illegal attempt to divide by 0. Okay, that's good. And the program ends. Now, that's good in that I could have put that into a loop instead of an if statement to force you to put in a number that's not equal to 0, as an example. All right? But the problem is, what if I do this? What if I run the program again, okay, and instead of doing it like this, I ask you to input the numbers. So I ask you to input the first number and input the second number and then do the calculation, okay? So instead of saying int x, int y, etc., what if I do this? And I'll come back and I'll just remove this. We'll have the int z in here also, okay? So if I come in here and I say this, write, enter first number. X equal convert dot to int 32 read line. Okay, that's all cool. Now I'm just going to copy all that. And now I'm going to say enter second number. And y equals this. Okay, now when I run this, okay, enter first number, 17. Enter second number, 0. Still got exactly what we had before. Okay, that's all fine. Run it again. I could put this in a loop. I'm not, but I'm going to run this again. Now let's put in 17 and 4. Okay? Since it's doing integer division, it's throwing away the remainder. And that's okay. I don't really care. The problem is, what if I do this? All right. Now I have what's called a format exception. It was expecting a number. I put in something non-numeric. Does that make sense? All right. So how am I going to deal with that? You're going to get. I'm going to give you a hard copy of a program later that shows this, but I want to show you this right here. So I'm going to say here, try. All right. And what I want to actually do is I want to take all this stuff here and put that in the try. Now what I'm saying is attempt to do this and attempt to do this. All right? And in fact, I can grab all of this information that you see right here, everything except for the read line, which I really could put in there, but I'm not going to. All right? So that's all okay, but if you notice in here, I still got, it's red. Because when you do what's called a try, when you're trying to do something, you have to catch something. So if you remember, it just told me about a format exception. And I can call this whatever I want. I'm going to call it FE for format exception. Okay? Again, you can call it anything you want. And if that's the case, Well, I've got choices now. Okay? The first thing I could do is just do a right line. The following error occurred. Okay, so I'm putting that in there as a right line. And then I'm going to put on the next line here, right line, FE dot message. Let's see what that does. All right. So I'm going to save this and run it again. Now I come in here, enter first number, hello. The following error occurred. That's the error that the system gave back that said the string was not in the correct format. All right? And the program ends. But the point is, I didn't get, an exception. I could have, instead of doing this, I could have said, you know what? Okay, that error occurred. I'm just going to say, I could come in there and I could check what the number was, and I could set it to something valid, for instance. I could do that. Okay? And that's what this chapter here is all about. So what we're doing, what we're working towards is as much as possible. You ever heard the term idiot proofing? We're trying to idiot proof the program, which means that any idiot can run it but not break it. That's what you want for software. All right? In an ideal world, you may or may not have heard of this, but it's the truth. For example, if you're talking about a website. Now, in an ideal world, the website's up 100% of the time. Makes sense, right? That's what you want. All right? But what do places shoot for? What do you think? It's not 100%. What do you think they shoot for as far as uptime? How often the website is up? Anybody guess? It's actually 99.999. All right? So it should be up 99 and 999 thousandths of the time. And typically that breaks down to something like about a minute a month on average. All right. Now remember going through this with Charter, and arguing with them because that's what they claim their uptime is like that. And I called the guy and I said, I understand things happen, weather happens, you can't affect that. I get that. I have no problem with that. Okay? And they're like, good. And I said, what I have a problem with is when the weather does go bad and you're down for 3 days, why don't I get a credit on my bill for that? Because it's not available to me. And he started talking. I said, wait a minute. Because your answer is bull. And I said the magic word after that. I said, no matter what you say, it's crap. It makes no sense, and you're wrong. And it was just silence on the other, because he had nothing he could say. Now, that's Charter, and I might be miffed, okay? But think about it. There was, I remember reading about it. I don't remember what it was. There was some kind of a problem last week on the internet where a bunch of sites were hit, all right, by hackers and the like. But think about it. Think about if, as an example, Amazon goes down for a day. It's not inconceivable that could cost them $1 billion with a B dollars. They have people hitting it from all over the world. All right? So you want to write, as much as possible, you want to write idiot-proof code so that if something happens that shouldn't happen, you handle it the best way you can. And if for some reason, if it's catastrophic, you can't, if for example, the power goes out, some terrorists come in and they're able to get to the power grids. There's really probably very little they're going to be able to do about that. All right? But what you want to do is you want to make your system as uncompromised as possible. And that's what we're talking about in this chapter. All right. So learn about exceptions, the exception class. Remember we talked before how everything kind of, when we talked about classes, cascades from the object class, and that's at the top, and everything comes from that. Well, you look at exceptions, everything works its way down from the exception class. All right? So every exception is part of the exception class. In fact, what I could have written here, if I wanted to, is we could have written here exception, just exception. The problem is sometimes with programming languages, if you just put here exception, okay, well, exception E, then this would have to change to E. All right, and it doesn't have to be E. You can call it whatever you want. All right, I don't know why that's, oh, because I don't have the curly brace there. All right, so I could have done that. The problem is sometimes when you're working with programming languages, and Java is really more a culprit of this than C# is. What happens is the system thinks you did something that's an exception, even if it isn't. All right. So in other words, the software is trying to take over and say, "Oh, you didn't probably mean to do this." Yeah, I did. So if you're ever going to use that exception, you should use it with care. All right. Plus, if you look at this, if you look up on the screen here, if I go into Google and I type in C# exceptions, it's going to give me a list, and somewhere it's going to give me the thing from MSDN, which is what I'm looking for. Exceptions and exception handling. All right. And what they start showing here, there's an overview, there's related sections, etc. System exceptions, C# keywords, try catch, exceptions, exception hierarchy. I'm going to try that one. All right. Now, when you look in here, here's some of the major exceptions that can happen. You're going to see one of these in just a little bit. All right. Now, the problem is, what if I'm writing a real simple program, kind of like we did even last semester in the JavaScript class? All right. Remember when we did that miles per gallon program? Okay. So we want to set it up. So let's say that you enter miles, and the miles that you enter has to be between 0 and 1,000. Okay. And then we ask you to enter gallons, and that has to be, let's say, between 0 and 50, something like that. All right. Well, if somebody goes in for the miles, fat fingers, and instead of putting in 1,000, they put in 10,000. All right. We can catch that with an if statement. You all know how to do that. But if I want to use exception handling, there's no exception in here that says miles out of range. There isn't one that was written for that. So what you can do is, if you don't have exceptions that exist, you can write your own. That's also explained in this chapter. All right. When you do your last hands-on test in here, which will be, believe it or not, I think it's actually early next month. All right. That's how far away it is. Remember, we got a week of vacation coming up. All right. And for some of us, we got more than a week of vacation coming up. All right. But that last test, I haven't written it yet. I haven't looked at Evan's, so I don't know if I'm going to use his or not. But if I have my way, you'll probably have to write at least one of your own exceptions. You'll see how to do this in the chapter here. All right. So, compare traditional and object-oriented error handling methods. That's what we've been doing. Traditionally, what we did were things like if statements. Okay? Now, remember, the if statement works if you put in, we could check for 0, right? But the if statement doesn't work if we put in something non-numeric. So if you remember, we went from if statements. Remember how we went into the try parse? All right. That'll handle stuff too. So we can check in there. This is the program. I'm going to give you a hard copy of this a little later. You won't have to type it in or anything. All right. But we're asked to create an array with random numbers in it, doubles instead of integers. So I tried to go and write a bunch of comments in here, but this creates the array of 20 random integers. I'm sorry, random doubles. Then just to show it to you, I print them out. Okay. Then we come in here and we say, okay, you've got 20 array locations that are between 0 and 19. So I want you to enter a number between 0 and 19, and I'll tell you the value that's at that location. Does that make sense? So think about what a person could do. They could put in a number that's less than 0. They could put in a number that's greater than 19. Remember, with 20, it's 0 to 19. They could put in something that's non-numeric. They could leave it blank. So when you look at this, what are we doing? Well, notice again, it's in one of these try statements. So I tell you to put it in there. And I read it in as a string. Remember, everything in a read line is automatically a string. But before, instead of trying to do a convert, in the past we would have done something like this. We would have said something like subscript, which is the value. Subscript equals convert dot toInt32 read line. And we did this for a long time. You know how to do that. You know what that does. The problem with doing that is if I come in here and I put in something non-numeric, it blows up. So rather than putting something like this in there and having it blow up, we're going to read it into a string variable. So that'll handle anything. Numeric, non-numeric, blank, whatever. Then we're going to come in here and try to parse that. All right? If we're not able to do that, then we write, you must enter an integer, please try again, and we ask them to try it again. And the whole thing is inside of a loop, so it'll just keep going and going and going and going and going. All right? But I also set it up so that you can enter a number between 0 and 19, but if you want to end the program, you can put in -999. You know this as well as I do. -999 does not fall between 0 and 19. So what we do is we come in here and we say, if this didn't work, ask them to do it again. All right? If it did work and you put in a number between, a valid number, okay, it's going to come in here and it's going to try to do this. The problem is, what if I put 1,000 in there? 1,000 is not between 0 and 19. All right? So what's going to happen is it's going to come in here and it has to check and it says, hey, if the number you put in there was -999, you wanted to end the program. So if that's the case, then just write normal program termination, do a read line, and get the heck out. You've done that kind of thing before. All right? But if it wasn't -999 and it was either less than 0 or it was greater than 19, we want this to print. And it'll say error subscript out of range. So you'll notice that if I run this for you, all right, those are the numbers that I automatically generated. I generated 20 random numbers between 0 and 100. It could have been anything, but those are just the ones I did. All right? So I come in here and it says, okay, enter a number between 0 and 19. Well, if I enter a 0, it says it was out of bounds. And the reason for that is I set it up so that's actually 1, 2, 3, etc. Okay? So I didn't have to do that, but I'm going to put in here, for example, 13. And if this works now, that should say 53.56. And you see that it does. Now I could keep entering all the other numbers to show that they're valid, but I want to do a couple things here. First, I want to put in a number that's out of range. See where it says error? Index was outside of the bounds of the array? That was what was generated when I did that message thing. The system generated that to let me know there was a problem. All right? If I put in here hello, that's in the if statement that I put in that says you must enter an integer. Please try again. And it asks them to try it again. So when you think about it, pretty much at least, this program is now idiot-proofed. It will handle non-numeric input, including blank input. So it handles that. So you saw non-numeric and you saw blank. It'll handle things that are either too small or that are too big. And if you put in a valid value, it'll give you the result. So what we have achieved pretty much is idiot-proofing the program. That's what we're trying to do. All right? Again, you'll get a copy of this in just a couple minutes. I also have your tests, like I said, and you'll get those back today too. All right. So that's the comparing the traditional and the object-oriented. Use the exception classes toString method and message property. Well, I just showed you the message. We'll look at the toString in just a minute. Catch multiple exceptions. Well, if you look at the example here, I just have one exception that I'm catching. What if something happened that wasn't that? So what if I had some kind of an error that was an index out of range exception? Whatever it was. What if I had some other kind of error? I can put as many of these catch statements as I need to put in. I could literally put in hundreds if I needed to. But they must go from the most specific to the most general. So in other words, If I came in here and I wanted to just do a regular exception, I'd have to put it under this one because exception is more general than index out of range exception. The good news is if you make a mistake and you put it the wrong way, I believe the compiler gives you an error message, and it lets you know that. It's unreachable code. Because if you put the most general exception first, it could never get to the more specific ones. It would always call the general one. So they must go from specific to general. All right? But you can have as many of them as you want to or need to have with multiple exceptions. All right, examine the structure. So they're going to talk about actually what's happening when you do a try parse. They brought this up to you in an earlier chapter, but now we're going to talk about it in more depth and breadth of coverage. All right? We'll use what's called the finally block. Okay? So what we've looked at quickly so far is you've got a try statement. And that's in curly braces. And you put one or more lines of code in there. All right? But if the try could possibly fail, then you need a catch statement. And you need to say what it is you're catching. Just for example, just exception E. Again, you call that anything you want. And we might have some lines of code in here. Okay? What I want you to understand is you're running through the try. You do the first section in the try, and it fails. Everybody with me? For some reason, it fails. That means you go directly to here. You cannot go back to these other four statements. There's no go-to in here where you can do that. Those are just, they won't run. And if you do these, and this works, 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 you skip the catch. Does that make sense? But sometimes, let's say you've got a database open. Whether your try succeeds and you do no catch, or whether your try fails and you do a catch, you still want to close the database when you're done. All right? That's why you use a finally. That has to go at the bottom, and it's optional. But if you put a finally in there, it's typically done for what's called housekeeping operations. Closing a file, closing a database, etc. That's on your test. All right? But the finally is optional. Okay. Handle exceptions thrown from outside methods. Sometimes you don't want the routine that through the method, you don't want that routine to handle it. You want another routine to handle it. We'll look at that in just a bit. Trace exception objects through the call stack. All right. If you remember when I showed you this, when we ran that one earlier, when I got the error messages, there actually is a way that you can trace it. What the call stack is, it says what method called, what method called, what method called, what method, etc. And what you can do is if you find an error in your code, you can do what's called basically rewinding the call stack, which says this was where the error was. What called this? Oh, there's not a problem there. What called that? What called that? So you work your way back up what's called the call stack. All right. Finally, again, you can recreate or create rather your own exceptions. I gave you that example with the thing that we talked about for miles per gallon. And then it's possible to do what's called rethrow an exception. Well, that's what this chapter is about. And we've already gone over a lot of it, all right, in the way that I'm showing it to you. So I know one of the things on the test, directly or indirectly, is they ask you what an exception is. Those are always popular ones for the, and I don't have the test with me, but those are always popular ones for, the 4 or 5 fill in the blank ones you have. A blank is, so you should know. It's any error condition or unexpected behavior in an executed program. All right? So it's not a good thing. It's either erroneous or it's unexpected. And typically, if it's unexpected, it will be erroneous. All right? And they give you some examples. I'm not going to read these to you, okay? The way that you try to handle exceptions when you're using object-oriented programming is you use what's called exception handling. I believe that's also on the test. All right? So you should know what an exception is, and to handle exceptions, you use exception handling. All right? Both of those should make sense to you. If you notice on the page here, I'm on the bottom of the next page, the bottom of page 490. In C, all exceptions are objects that are instances of the exception class or one of its derived classes, so one of its children. You all know what that means now because that was what the last chapter was that we just went over. All right, I believe that's on your test. The fact that all exceptions are instances of the exception class or one of its children. So here are some popular exceptions. This is the chart that takes up all of page 491 in your book. I'm not going to go over any of these. It would be in your best interest, not for here, but I'm talking about this is the kind of thing, okay, it's graduation time. It's beginning of June, okay? Colin's up for a job as a C# programmer. They may ask him to do a snippet of, write a little bit of code, and they say, oh, and handle any exceptions that can happen. You may or may not have the internet available to you. You probably didn't bring a C# book in with you to the interview. So this is the kind of thing that you have to remember. The good news is, when you start to put in these exceptions, the IntelliSense does kick in. That's the good news. All right? But you have to have some kind of an idea of what it is. So the major exceptions are shown on the page here. The ones that you're gonna handle most often, all right? Argument, when one of the arguments provided to a method is not valid. It's expecting 2 ints, and you give it an int and a string, as an example. Arithmetic. You're doing some kind of a weird thing with arithmetic that the system can't understand. Format exception. Again, it's expecting A and you're giving it B. Something in the wrong format. A real popular one for that is it's expecting an int and you give it a double type of an idea. Index out of range, that's anything with arrays. And the other one that you're going to get most often is going to be this one right here, I/O exception. We haven't dealt with files yet, but you'll have an I/O exception if I try to open up a file that doesn't exist. All right? If I try to write to a file and I don't have permissions to write to that file. If I try to read from a file and I don't have permissions to read the file. Do you ever do that? Do you ever go out to a website and then, because I've done this just to see what happens. Go out to a website, then you try to go back one level in the website. You try to go like up one level in the hierarchy, and a lot of times it'll come back and it'll say forbidden, if that's ever happened to you. All right? If you don't want that to show, probably it threw some kind of an I/O exception. You did not have the rights to that. So what you did in the catch clause for that is you just said, print out some kind of a message that just says forbidden. That's how they handle it. All right? Those are the ones that you're going to get most often. Any of these could happen in the right or wrong circumstance, but those are the ones that I just mentioned to you that are going to happen the most often. All right? So most exceptions, as they mentioned on the top of 492 here, derive from one of 3 classes. System.exception, application exception, system exception, application exception, or exception, which is a parent of that. What does that mean? This right here means that somewhere under object, remember that's the parent of everything, somewhere under object, there's a thing called exception. Somewhere under exception, there is one thing that's over there that's called application exception. All right. And there's another one under here that's called system exception. So what's the difference? System exceptions are typically going to be things that the system finds. Whereas a lot of times, at least, application exceptions are errors you put into your application. So in other words, if I want to go and write my own exceptions, they're either going to be probably of type application exception or of type exception. And again, you're going to see that before the end of the period today. All right. Purposely generated exception. This should look familiar to you. They divide by 0. Exactly what I did, but they use the miles per gallon where I just used X, Y, and Z. All right. Now, if I were to run this from an actual command line, this is what would come up. I ran mine from a GUI, correct? Okay? I ran it from within Visual Studio. So that's not a GUI. It's GUI, and then I ran it from within Visual Studio. If I ran it from the command line, this is what I get. So the difference between that and what you saw in the example that I gave you, the one that was here, all right? So again, when I come in here, and it's pretty much idiot-proofed right now, but if I came through here and just said, let's do back what we did before, equals 17, equals 0, and we say z equals x divided by y. We run the program. It should immediately blow up, and we get this. System.divide by 0 exception. The reason I'm showing you that is that's exactly what you have here. But here you're seeing it from a command line. Where I showed it to you, you were seeing it from the GUI itself. All right, from Visual Studio. All right. Now, again, more stuff that's on the test. There's all three of these terms that are bolded here are on the test. I think mission critical and robustness, they're either the fill in the blank or they're the definition at the end of the chapter. So this is in your book on page 494. They mention here, mission critical refers to any process that's crucial to an organization. All right? What does that mean? Well, I mean, look at it this way. Let's suppose that it isn't going to happen, but let's suppose I'm a race car driver, okay? And I'm the only one who can drive this car. If I have to, I can even do some servicing on it, okay? Now, it's time for the big race. And I go there. There's my car and there's everything else. But unfortunately, somebody told my team it was in a city in a different state. So they're all gone. I'm the only one there. I'm the most mission critical because I'm the only one who can drive the car. All right, so I'm mission critical. They're not actually mission critical. I mean, if you imagine if it's a short race and I can drive the whole race without making a pit stop, I don't need them, so to speak. All right. On the other hand, think of it's the other way. I get sent to the wrong city in the wrong state. The car is with the whole pit crew, okay? But no one can drive the car. Okay? None of them technically are mission critical. What's mission critical are two things, me and the car. Does that make sense? Because if you understand that, that's what mission critical is. All right? Fault tolerant are applications designed so they continue to operate, possibly at a reduced level when part of the system fails. Well, the example I just gave you wasn't a good one. But have you ever seen that, for example, okay, let's assume that the power goes out here. Okay, we have real bad weather like we had the other night, so power goes out. And they have a generator that kicks in, but it's a small generator, and it's servicing this entire building. Okay? So in other words, the lights are on, but they're flickering, and they're real low, and I tell you, you probably shouldn't have your computer on, and if you do, you should save, etc. All right? That's a fault-tolerant application. It's still working, but it's not working at the same level of robustness as it would be normally. All right? So robustness, as it says, is the degree to which a system is resilient to stress. If you don't know what robustness is, you're not married. All right? So I can't think of anything that happens in your life that on a daily basis puts more stress on your relationship, or on you and your partner, for that matter. All right? So that gives you here 2 truths and a lie. Now, again, if this doesn't make sense to you, key in this short program that she calls exceptions on purpose. This is almost identical to the one I just keyed in for you. All right? That's all the code. That's everything. Again, if you're going to have a write and a write line, you're going to have, yep, she's even got the using static system.console in there. So what is that? 10 or 15 lines. So if you tell me, well, I don't get this stuff, I'm sorry, I don't feel sorry for you. then start keying this stuff in. All right? And if you do that and you run it, she shows you how it can break. This is real bad. Debug and close program. I mean, what it's saying is something happened and it's so bad I can't handle it. Now, if you do choose debug, what it's going to do is it's going to try to bring up the debugger, but in a special mode where you can look at the underlying hex code. You know, it'll be a bunch of zeros and X's and a bunch of other stuff, all right, which you may or may not understand. But if you try to run it, this is all the stuff that you can get. Because she shows. Now notice, it says enter an integer. You put in something non-numeric. So it says system format exception. That's one of the ones I showed you. So you run it again. Enter an integer. You put in 7.7. That's another format exception. But it also has a problem because it's trying to parse it right here. So it's showing you, this is a stack trace. It's trying to show you what it tried to do. All right? Enter an integer. Put in something valid. All right? But they purposely tried to divide that by 0. So you get another error. So again, if this isn't making sense to you, take the time and key in the programs. I believe you even have the code, all right, for these programs that are in the book. So if you don't want to key them in, run them. Make some changes to them. See what happens. All right. So this comparing traditional and object-oriented, this is what I showed you before. Yeah, we can say use if statements. Okay? Now I'm going to say something that's in this chapter but not directly in this chapter. All right? And that is, what you'll find is you don't find a boatload of try-catch statements in code because they can really slow down processing. Okay? They slow it down a lot more than if-else's do. So if you've got a mission-critical app, if I'm doing something for NASA, I'm going to be using if-else's. I'm not going to be using try-catches. Because if I'm off by a second, you might miss the planet you're going to, or you might, miss the ocean if you're coming back in, or whatever. So, understanding object-oriented exception handling methods. This is the bottom of 498. We'll go through this section, then we'll take a break. All right? So it says object-oriented exception handling uses try, catch, and throw. All right? We didn't even look at throw yet. It says you try to do something which can conceivably fail. Well, and not to be funny, but when you think about it in a computer program, technically, any line in a computer program can conceivably fail. All right? So that's what you put in the try block, something that may or may not work. All right? Now, it says there a method that detects an error condition throws an exception. Well, when you tried to divide by 0, that threw, all right, the divide by 0 exception. And what we did in our code was we tried to catch it. So it's try catch. All right, we'll look at finally in just a minute. So it says when you place a block of code into something that can go wrong, you use a try block. With the keyword try, you need curly braces after it and one or more lines of code. Then you've got a catch block. The catch block has the keyword catch, then it's got parentheses and the type of error you're trying to catch, followed by a name you're going to give it, followed by curly braces, which says, what do you want to do with that? So this is the syntax for it that's shown here towards the bottom of 499. Now, where they've got XXX, that'd be some kind of thing that you would put in there. So you put in here code. That's code that may fail. This is the exception that you want to handle from that. This is what you want to do if there is the exception. All right. In essence, that's exactly what we're doing right here. So they show another example. So notice how they've changed this. Now if you attempt to divide by 0, we didn't put a divide by 0 exception. We put that generic exception. So if we try to divide by 0, it's going to come up and it's going to just set your MPG to 0. And it's going to say you attempted to divide by 0. All right? And it says you got 0 miles to the gallon. So you'll notice that they do this and then they run it. And they give it valid values, 300 miles, 12, 25 to the gallon. 300 miles, 0, you attempted to divide by 0. We're idiot-proofing the program. All right? And there's a reason that it's called that. All right, not trying to be funny or snide or anything else. You know, you want to set it up so any idiot can run it. And they've done studies on what I'm about to tell you. That typically what's going to happen is little kids can pick up on this so much faster than adults can. Because they'll screw it up once or twice, and then they'll know, oh, I got to do this. But adults will screw it up once or twice and keep screwing it up. Especially adults who are not real computer savvy. All right? You know, when my mom, who loves to sit there and look at everybody's pictures out on Facebook, tells me she's having too much trouble with Facebook. And she shows me what she's doing, and I have no clue as to what it is she's trying to do. All right? And then I look at little 4-year-old kids who can get on and do it and just peruse their way through it. All right. So we're on page 502. Let's take a break. It's 8:55. Let's come back, please, and let's make it just 9:05. All right, we'll try to see if in the next, between here and 10, or 9:05 and 10, we can finish the chapter. All right?